So here in this video, we're going to look at the second problem on the 9192 worksheet. It says to write out the first four terms of each sequence defined by the recurrence relations given below. All right, so what's a little bit different about these problems is that the sequence is described in what we call a recurrence relation. Okay, so you can see for part A, we're given the sequence A sub n, where A sub 1 is 1, and then we're given this rule that says that A sub n plus 1 is equal to negative 1 of the n plus first power times this quantity A sub n divided by n plus 1. Okay, so we are going to construct subsequent terms of the sequence by using previous terms. Okay, so we're going to do this in this recursive fashion. Okay, and so let's check out how that's going to work. So first term, of course, is just a given. This is this A sub 1 is equal to 1 part. So then to build A sub 2, we're just going to use this little recipe right here. Okay, so if I plug in n equals 1 into this recipe, on the left side I'm going to get, well, A sub 2. And then over on the right I'll get negative 1 to the second power, right, 1 plus 1, times the quantity A1 divided by 1 plus 1. And A1, we know up here, is equal to 1, so I plug that in, and that simplifies to a half. So the second term of the sequence is 1/2, and now I'm just going to keep doing that, right? So for A sub 3, notice if I plug in 2 for n into this recipe, I'll get A3 is equal to negative 1 to the 2 plus first power, that's a negative 1, and then I'm going to get here A2 divided by 2 plus 1. So plugging in 1/2 in for A sub 2 and simplifying, I get that A sub 3 is equal to negative 1/6. All right, and then likewise for A4, this turns out to be negative 1 over 24. All right, so first four terms there, 1, 1/2, negative 1/6, negative 1/24, and so on and so forth. Okay, so these are the first four terms for part A. Let's now turn to part B, and I'm going to delete all that out. All right, so now for part B, it says we're given the sequence f sub n, where n starts at 1, and here the rule to build subsequent terms is that f sub n plus 2 is equal to f sub n plus 1 plus f sub n, and then we're given that f1 and f2 are both equal to 1. All right, so here we are actually told how to build the subsequent term using the previous two terms, right? So let's see how this will work. So first off, from this condition right here, we know that, well, f1 is 1, f2 is also 1. So then if I want to know what f3 is, okay, well, that's where this recipe is going to come into play. And notice if I plug in n is equal to 1 into this recipe, what am I going to get? Well, I'm going to get that f3 on the left is equal to f2 plus f1. And we're given both of these is equal to 1. So 1 and 1 is 2. All right, so now we're just going to repeat this. To build f4, right, we're going to plug in n is equal to 2 into the recipe. And that's going to give us that f4 is f3 plus f2. So I'm just adding these two previous terms, right? 2 plus 1 is 3. Okay, what's f5 going to be? That's going to be 2 plus 3 is 5. f6, what's that going to be? 5 plus 3. And I think you get the idea at this point. Okay, so here, our sequence, f sub n, first couple terms here, 1, 1, 2, 3, 5, 8, then it'd be what, 13, right, because 8 and 5, and 21, so on and so forth. Okay, now this is a rather special sequence. This is what's known as the Fibonacci sequence. You might have seen this somewhere before. It was first described by Leonardo Fibonacci in relation to a group of rabbits with particular breeding habits. Okay, and it was looking at this question of how the number of rabbits would propagate, and turns out to have all these really amazing properties. Shows up in a lot of different places in math and science, in nature, in art, so on and so forth. So if you're interested in the Fibonacci sequence, maybe do a quick Google search. You'll find all kinds of pretty fascinating stuff. All right, well, that's going to do it for this problem. Thanks so much.